Hi, and thank you for watching. Please click on the question that you want the help with, or you can click on the section and it'll go through that section. So either section 1, part A, section 1, part B, or section 2, and you can click on individual questions, or if you want, just stay here, don't click on anything, and I'll go through all of the questions one at a time. So we're going to start with section 1, part A, and we have our first question. The function f is defined below. For what value of k, if any, is f continuous at x equals 3? So this is very similar to what we did in class. We have the 3 steps that we're going to do. 1 is set them equal, 2 substitute in for x, and then 3 solve for k. So let's go ahead and do that. We have step 1, if it writes, step 1. This is a new thing. I don't know how to write with this yet. So we have k equals x squared minus 9 over x minus 3. And so that's step 1. Step 2, we're going to substitute in. And the x value that we substitute in is wherever the discontinuity is. So it's telling us that we want to make it continuous at 3. If we didn't do this, it would otherwise be discontinuous at 3. And then that's verified here. These also match. So we're going to plug in a 3. So we have k equals 3 squared minus 9 over 3 minus 3, which gives us 0 over 0, and we have apparently destroyed the inverse because we've divided by 0. So clearly this was maybe not the best thing to do next. Maybe we should have gone here and thought about this for a second. So if you look in the numerator, you should identify that we have the difference of squares here. It's x squared minus, and then this would be 3 squared. So this comes out to be x minus 3. Whoa, okay. And this is x plus 3. Okay, and then in the denominator we have, this thing is really hard to write with. So x minus 3 still in the denominator. So you see that these can cancel out, and we end up with x plus 3. Now we have removed that discontinuity, and now we can actually kind of sort of divide by 0 because we got rid of the part that was the problem. So if we go back to step 2, we have k equals, substitute in the 3 that they're asking us for here. So 3 and then plus 3, and we see that k equals 6. That was step 3 right there where we just kind of solved for k. And so you should get the answer of D. Okay, let's go on to question 2. So the piecewise function m of x consists of 2 linear segments, which would be right here, if you can see where my mouse is, and then right here is the other one, and portions of a parabolic function. So here's part of a parabolic function, and then the sinusoidal function is the other part, which you see right here. Okay, but that's not really important. They're just kind of throwing that in there to confuse you. You really don't need to know that. So here's where the question gets confusing. If b of x equals 3 times m of x, for which of these values of x does b of x equal 9? Okay, so I want you to notice that b of x equals 9. That means that we can replace b of x with 9, or we could replace 9 with b of x any place that we see it. So here, do you see that we have b of x here? Why don't we replace that with 9, since b of x and 9 are the same thing? So I'm going to do that. We would have the 9 equals 3 times m of x. Okay, and it may be, wow, this is really hard to write with, guys. That's an m. So if I divide both sides by 3, you see that I can get m of x by itself. So 3 equals m of x. Okay, so if you look back at this original question, it says if b of x equals 3 times m of x, for what values of x does b of x equals 9? What that's really saying is this: where is m of x equal to 3? That entire question up here could be summarized with just this down here. That's it. That's the question. So if you look at the graph, it does tell us that it's m of x. This is m of x. So it's saying where does it equal 3? And if you look at that graph, it equals 3 right there. So even though it's hard to see the numbers, that would be at -8. This number right here is -8. And so C would be your answer. So really, it's a very, very, very confusingly written question, but it's actually asking something really straightforward if you just kind of take or use what you have to sort of get rid of stuff and make it a little easier to see. So hopefully that makes sense. Okay, question 3. We want to factor to find the x-coordinates of any holes, or another term for that would be removable discontinuities in this graph. So if you'll remember, holes are the ones that you can cancel out, they're removable, and then the other one that you cannot cancel out would be the asymptotes. Okay, so I'm going to go ahead and copy this problem down. We have x squared minus 7 over x minus root 7 and x plus 3. Okay, and if you look in the numerator, what do we have? Yes, that's right, we have the difference of squares. Even though 7 is not a perfect square, that's okay. So we have x minus the square root of 7, which is coincidentally square root of 7. And then in the other one, it would be the same thing, but with a plus sign. All over this denominator, which doesn't change. X minus root 7 and x plus 3. So we see here that these are going to be removable. So that's my removable discontinuity. The x plus 3, that would be my asymptote, but it's not asking for asymptotes. So you should see that it's going to be positive root 7 as your answer. If you don't see that, I'll show you real quick here. We would set x minus root 7 equals to 0, and then add root 7 to both sides. So x equals root 7. Okay, so that's all you're doing is you're looking to see what could actually be removed, and then that's your answer. All right, on to the next question. Number 4, we have this piecewise function. We call it f of x. You see that this is part of a parabola, and then this is part of an absolute value, but that's not that important. And it wants to know the value of f at -2, so that's really not a terrible question. Here's -2 right here. If you look up here, that's got an open circle, so you can't use that. So this would be the value that we're looking at, this part of the function. And so our answer would be A, which is 0. Okay, question number 5. Find f of -5 if this is our function. So we want to know what the value is right at -5. So this little equal sign that's down here, that's important. That's telling us that this would be the part to use because that's bigger than or equal to -5, and here it's exactly -5. So this is where we're going to plug that -5 into. So we have -5 plus 5, and that equals 0, so your answer should be D. Okay, number 6, we have the function, which I'm sorry, it looks kind of weird on here, and then we also have the table, and the table's not really important. It's kind of just there for your own fun to see it, but it actually, I think, if anything, probably confused you. Hopefully not. So it wants to know where is the function undefined, and maybe the best way to do this, and unfortunately I don't have a ruler or anything, but if you picture laying a ruler down right here, and rulers normally are straight, but this one is non-Euclidean. So that's a pretend ruler, and if you slide the ruler along here, you're looking for where it's not touching any function. So as you go along, you get to here, and you see that there's nothing there from -3 until -2. It's just empty space, okay? And then if you keep going, you're still going to be hitting function, still hitting function, function, function. So all the rest of the way until 6, from -6 to 6, you hit function, except for in this little spot right here. And so the interval where the function is undefined would be this. And if you're curious about the square brackets, that's interval notation. Remember that we use, like, it could be with the parentheses, and then like where it actually gets to that point. You remember that notation? I hope so. If not, that's okay. It's just saying that it actually is undefined at -3 and at -2. And actually, if anything, this should be parentheses since it is defined at -3 and -2, but we're not going to quibble about that. I don't know if quibble is a word, but that's okay. It's a word now. Okay, so that's the answer to that one. All right, so we're now at section 1, part B. Here's number 1 of section 1, part B. We want to find the vertical asymptotes. Remember, the vertical asymptote is where it does not cancel out, where you cannot get rid of stuff. So if you look at here, I can remove this x plus 2, so that's our removable discontinuity. The x plus 4 and the x minus 4 cannot cancel out, and so this is our asymptote. And remember, the sign has to flip, so this is our answer, D. It's a terrible circle, but that's okay. It's not even a circle anyway. If you don't know why it has to flip, I'll just show it real quick. We would set that equal to 0. Remember, vertical asymptotes happen when the denominator is 0. And so you would subtract 4 from both sides and get -4. Okay, so here we have another piecewise function. It's got a lot of stuff going on, and this was actually the same function we used on that question in part A, but it's a different question. But part A was kind of warming you up for it. So we have this case type question. Remember, we want to go through each one individually, rule them out or rule that it's true, and then when we're done with that, then we look at the answer choices. So case I, there are 3 values of x where g of x equals -1. And actually, that's a typo. This should say 2, and I think that your test says 2. It should say 2. So -1 would be, there's be 1 right here and 1 right here. And so I is true because there's 2 and that's the 2. Okay. Number 2, the domain of g of x is -6 to 6. Well, as we saw in section 1, part A, it does go from -6 to 6, but that's not the domain because we're missing stuff here. So the domain would actually be every number from -6 to 6, but not including from -3 to -2. So that means 2 is wrong because we do have that blank space there, okay? And then 3, there's exactly 1 vertical asymptote. Well, we do have some jump discontinuities, but we don't have any asymptotes. And so 3 would be wrong. So that means that A is your answer. Actually, I'm thinking of what your test has. It does have a 3 here. It's that this is a positive one, so it'd be 1, 2, 3. I don't remember which one your test has, but I is correct, whichever way that it has it. I hope you can see that. Okay, number 3, here's our rational function as x approaches infinity. So if we're looking at the graph, as we go more and more in that direction, it's asking us what the graph is doing. And essentially what it's asking us is for the horizontal asymptote. So if you remember our tricks, I can't write them all here because it's really hard to write here, but we have trick number 1, if it's equally balanced, you look at the coefficients. See how ugly that comes out? Okay, number 2, if it's bottom heavy, then it's 0. And if it's top heavy, then it's going to be positive or negative infinity. So in this case, we have only 1 x up here. We have 2 x's down here. So that would make it bottom heavy. And so my answer is 0. Okay, number 4. This is our function. For what values of x does m of x equal 4? Now remember, this is a calculator section of the test. I don't know if you saw that on the initial part or the first page of this. But this is so far the first question that we've actually needed a calculator for. So you'll notice that on the AP test, a lot of the calculator section questions, you don't really need a calculator. The reason they put them on there is so that you have a few extra minutes to work them out since you do have more time on the calculator section. Okay, so we need to use the calculator to figure out, and basically what we're solving for is the x. We know that the y, or the m of x, is 4. We need to know what x value that would happen with. So it could be in either of these. We don't really have any way of ruling it out. This tells us what happens with the x's, but it doesn't tell us anything about what happens with m of x or with the y. Okay, so the way you want to do this is in your calculator, you do solve. I look like I'm 5 writing this stuff out. Okay, so I'm going to try the first one first, the 3x squared. So 3x squared minus 3, we want that to equal 4, and then that is from solving in terms of x. Okay, I realize that you guys don't have calculators at home that can do this, but hopefully, you know, maybe at the beginning of class you can come in early and just work it out, just make sure that you understand how to do it. So if you solve that, you end up getting positive or negative 1.528. Okay, and remember, if you don't ask it for a decimal, I think it gives you, I think it's like root 21 over 2 or something like that. So if you want to get a decimal, you need to either stick a decimal after one of these numbers, it doesn't matter which number you stick it after, and then this would be times. Or the other thing that you can do is there's that little green button with a diamond in it. Push that. That's a diamond, okay? Push that before you hit enter, and then it will give you a decimal. So diamond. Okay. So the green button up at the top left. Okay, so that's that one, and then we're going to do the second one. So we have same deal, 1/4 x minus 5 squared plus 2. Remember to give it the equal 4. If you don't, it's going to give you an error, and then comma x so that it knows what to solve for. And when you do that, you get these two answers. And so that would make C your answer. Now I want to point something out. Technically C is not your answer because remember everything has to fit within these bounds. So the first function gave us this, the positive negative 1.528, and that fits in here because negative 1.528 is in between these two and positive 1.528 is in between these two also. But you see that 2.172 and 7.828 is not actually in here. So that means that this one wouldn't actually have the value of 4, technically. I left the answer like this, though, because I wanted to make it a little bit less confusing. I probably should have changed these bounds, and I didn't. But if you caught on to that, then that's really good, and you're way ahead of the rest of your peers. If you didn't catch on to that, that's all right, because, I mean, technically, that was kind of a trick question a little bit. So hopefully that didn't trip anybody up. But technically, these are the only two values where it would cross. These don't count because they're not in that interval. Okay. Number 5, determine the domain of the function. We see that we have an absolute value. We didn't really talk about absolute value in the workshop, but if you remember, absolute value just means that if you have a negative number in there, it becomes positive. If you start out with a positive number, it stays positive. So basically anything that comes out of an absolute value has to be positive. So the question is saying, what number can I plug in here that would make this 0? Because remember, when we're talking about domain, we're saying that it's all real numbers such that x is not equal to something, right? So in this case, obviously a positive 7 wouldn't work because we would have 7 minus absolute value of 7, which is 7 minus 7, which is 0. So you can't have 7. And the other one that it can't be is negative 7. Because if I plug that in, we have 7 minus, and then absolute value of negative 7 would be 7, which is still 0. So really, you can't have a positive or a negative 7, and so your answer would be C. Okay, number 6. So this, hopefully this didn't confuse you because it's a pretty straightforward question. It's asking you just for the types. So right here, we see that we jump from here to here, so that's a jump discontinuity. And then here, this little dotted line right here is not straight, but that's our vertical asymptote. And so 2 and 3 are true. Remember, a removable discontinuity would be like if we had a little hole stuck in somewhere and we don't see that, so I is out completely. And so our answer would be E. Okay, section 2, this is the free response section. So here we have this graph that we actually saw earlier. If you remember, this is linear, this is linear, this is part of a parabola, and then this is part of a sine function up here. And so it wants to know the domain of m of x. So you see here that we've kind of got a gap here, right? So there's lots of different ways that you could write this answer. It's not a very eloquent answer. It's going to look kind of ugly no matter how you write it, but really, I guess the most straightforward way to write it would be like a sentence. So you could say all real numbers from -8 to 5 except from 1 to, whoops, 1, 2, it doesn't want to write. Oh, because I'm at the end of the thing. Okay. 1, 2, 3. That's a 1 there. There we go. 1 to 3. So you could write it like that. You could try to use the fancy notation with this. Honestly, I think that it looks pretty junky though, and I'm really not sure what would be the best way to write it. I guess if I had to pick one, I guess I would say like -8 less than or equal to x less than or equal to 1, or that symbol means or, from 3 less than or equal to x less than or equal to 5. So I guess that would be how I would write it, but I think that looks terrible. Again, I don't care how you write it. You get credit no matter what, as long as you know that there's a blank spot here. Okay. Part B. So we want to know where this happens. As x increases, y decreases. So basically, as you move to the right in this graph, you're looking for places where it decreases, and there's 3 places where that happens. Right here, and right here. So if you notice, it's from -8 to -5, and then again from -5 to -2, and again from -2 to 1. So you could write each of those 3 separately, and that's fine. Or maybe you notice that it's going to be from -8 to 1, and actually these should be parentheses, which gets way more philosophical in math than I really want to get, so we're just going to say it's parentheses and then not be that stickler on it. So you could say from -8 to 1, or you could, separate the 3. It doesn't matter to me as long as you see that that's where that's happening. Okay. And then next one, as y increases, as x increases, y is constant. So we're looking for a flat horizontal line. And if you'll notice, there is none. So your answer, which I don't know why, whenever we get this answer, you guys get really confused about it because you don't know how to write it. You just write the word none, or doesn't happen, or there is not a place, or whatever, just so that I see that you know. Okay? The last one, as x increases, so as we go to the right, y is decreasing at a constant rate. Whoops. Constant rate. So this is distinct from these 2 questions. It is asking where it's decreasing, and there is that word constant, but it's not the same as either of these 2 questions. If you look at the 3 sections that we have decreasing, this one, and this one, okay? These 2 are decreasing at a constant rate. Okay, so we would have -8 to -5, or from -2 to 1, okay? So that's decreasing. This one, though, is not decreasing at a constant rate. It is decreasing, but it's not constant. So if you think about like spending money from your bank, right? Here's the beginning of the month, and you're spending money really fast. Your bank account is decreasing really fast. But then as you get to the end of the month and you're like, oh, I have no more money, the speed at which you're decreasing decreases. So you're still decreasing, but not as fast as you were here. So maybe here your bank account is going at like $300 a day because you're paying bills, but then when you get down to here, it's going at like $1 a day. So even though it's decreasing, this constant rate part is what kills it, and why it's not part of the answer, because it would have to be a completely straight line where the slope is the same all the way through. Okay? Part C, for what values of x is f of x greater than 0? I think this one is maybe one of the more confusing questions on this test. So if you were confused by this, that's okay. So I have a little line here. Well, first of all, let's talk about this right here. F of x greater than x. You know that we can write f of x like y, right? So really we're saying where y is greater than x. If you remember, that's this line right here. This is y equals x, right? That's our parent function. So if it's y greater than x, we're looking for everywhere where it's shaded up here. Remember, like in Algebra 1 where you colored with the colored pencils and you had to shade it up there? You remember that? Okay, so that's what we're talking about, is everything above that. So if we look at that, we have from here down all the way to there, right? So that's like -8 until, I don't know, it's like -3.5. Maybe I'm wrong. I'm not really sure. So -8 to -3.5, or, remember that symbol means or, it's a U. Or it could be from -2 to, I don't know, like -1.5 maybe? It's okay if you don't have the exact right numbers as long as you're in the right neighborhood. So this little section right here. Everything else is going to be y less than x. Okay? Okay, and then the absolute minimum value for f of x. Hopefully this didn't throw you off. The very smallest number is down here. It's asking for the lowest f of x, aka y, right? So hopefully you didn't pick this one because of you're thinking the smallest x, because it's not asking for the smallest x, it's asking for the smallest y. So your answer would be -4. Make sure also that you don't tell me -2, because again, it's asking for what the smallest y value is. It's not asking for at what x value the minimum happens. It's saying, what is that number right there? So 4 is your answer to that. Okay, number 2. So we have this piecewise function, and we want to look at it and classify each of the geometric figures, and I put shapes in parentheses, hopefully to help you. This question is super duper easy. If you thought it was really hard, you're thinking too hard. This right here is a triangle. That's all you have to write. And it's not even asking for what the interval is. If you wrote the interval, that's great. It would be from -6 to -2. But if you wrote something wrong with the interval, like if you put the wrong number down, then I'm going to have to count the whole thing wrong. So if it's not asking for the interval, then don't offer up the interval, because if you get that wrong, then you could have had this right, but you get the whole thing wrong, and you don't want to do that. Okay? The second shape from -2 to 2 is not a circle. And I know a lot of you guys wrote circle. It's not a circle. It's a semicircle. Circles go all the way around. Semicircles are only half. If you wrote half circle, I'll take that. That's okay. Even though technically a half circle is not a shape, but that's okay. All right? But not circle. Circle's wrong. From 2 until 7, we have a trapezoid. Okay, again, it's not asking for the intervals, so I'm not writing the intervals. If you wrote them, great. Just make sure that you wrote them correctly, because otherwise the whole thing is wrong. Okay, so now we want the total area enclosed by the graph of a of x and the x-axis. So basically, like, we're asking for this. This is really a geometry problem, but you're going to see in the second semester how this is what we spend a lot of the second semester doing. So the triangle, say A of the triangle, the area, that's a triangle down there, just pretend. So we have 1/2 base times height, which is going to be 1/2. The base is from -6 to 2, so let's count them. 1, 2, 3, 4. Good job. So we have 4 as our base. And then the height, 1, 2, 3, 4. Also 4. Well done. Okay. So we have 1/2 of 4 is 2, times 4 is 8. So the area of the triangle is 8. The area of the semicircle, that's a semicircle, not a sideways D. We're going to use pi r squared, right? That's for a circle. But wait, it's not a circle, it's a semicircle. It should be 1/2 pi r squared. Okay, so we have 1/2 pi. The radius is from here to the side, so it's 2. So these cancel, and we have pi. Okay, and then the area of the trapezoid, that's a trapezoid. The formula for that, hopefully you didn't have to look it up, is 1/2 base 1 plus base 2 times the height, which is going to be, oh, yeah, so on the semicircle, that's squared, 1/2 pi r squared. I bet some of you were sitting there at home, like, wondering what you had done wrong. I'm sorry. Okay, so this is 4 divided by 2 is 2 pi. I am so sorry. Pi r squared, not pi r. Okay, so back to the trapezoid. Base 1 is going to be this down here, so if we count that, it's 1, 2, 3, 4, 5. Base 2 up here is only 1. And then the height is 1, 2, 3. Oops, okay. So we have 1/2, this is going to be 6. And then 1/2 of 3 is 3, so 3 times 3 is 9. Okay, so it's asking for the total area. You need to add these. We have 8 plus 9 plus 2 pi. I bet you that some of you actually went in the calculator and you put in pi and you figured it out, and I think you get 26 point something or other. I don't know why you did that, because this is supposed to be a non-calculator section. And not only that, even if it were a calculator, why are you going to spend time plugging that in? You could theoretically write this down on the AP test and you would have your answer and you're done and you don't have to do anything else, okay? But I know that that's like disturbing to leave it like that. So you can write 17 plus 2 pi. But please don't go any further than that. Just leave it like that. Why are you going to do extra work and lose time plugging in pi when you don't need to? 17 plus 2 pi is fine. In fact, 8 plus 9 plus 2 pi is even better. Okay? Okay, so I'm going to write the area down here so we remember. 17 plus 2 pi. This one was 8. This one is 2 pi, which is about 6.28. And then this one is 9. That's what we got on the last part, okay? So it says a vertical line, x equals k. We don't care about that. We're just saying a vertical line, okay? Divides the area enclosed between the graph of f of x, or actually it's a of x. Sorry, that's a typo. Okay. And the x-axis into 2 equal parts. So which of the 3 geometric figures does this intersect? So if I'm going to draw a vertical line and I draw it here, did I divide the entire function in half? Well, obviously not, because here I have 8 plus 6.28 plus whatever is here is definitely more than what's left over here. So that was a stupid place to draw the line. If I draw the line, hold on. If I draw the line here, that's also stupid, because now I have 9 plus 6.28 plus the part that's left here, which is definitely more than what is left here. So I hope that you can kind of see where I'm going with this, and you just wish that I would be quiet at this point. You can see that you're going to have to draw a vertical line somewhere in the circle. I don't know exactly where. It doesn't really matter, because you have 8 over here and 9 over here. So it actually maybe should be over here more, but that doesn't matter. The point is, it's somewhere in this semicircle, because otherwise you're not splitting it in half. And so the answer is quite simply semicircle, or half circle if that's what you were writing. Okay, so I'm done, and if you have any questions, if any of that still doesn't make any sense, talk to me, find me, text me, something. Don't be helpless, but make sure that you understand this thoroughly before we take our test on whatever day of the week that is that we come back. Okay? All right. Bye.